question 5, we are given a diagram that looks like this. And we are asked, at time t, what is true of the distances traveled by the vehicle since time t equals 0? So first, we can see that the car is accelerating at a constant rate. This means that the car is accelerating at a constant rate. So, what is the acceleration of the car? We know that acceleration is the change in velocity over the change in time. And we know that the velocity initial, or that the change in velocity is velocity final minus velocity initial over the change in time, which is t final minus t initial. However, we know that the velocity initial is 0. So, the acceleration of the car can be written as v final over t, because our t initial is 0 as well. So, v final divided by t is our acceleration for the car. Now, in order to find the displacement, we can use the equation the change in x equals velocity initial times time plus 1/2 at squared. Because we are given the initial placement, we can just write that the x final of the car is x0, x initial, plus velocity initial times time, 1/2 acceleration times t squared. And if we plug in our known values, we know that we have our x initial plus our velocity initial, which is 0, times t plus 1/2, and our a, as we said earlier, is velocity final over time multiplied by t squared. And if we simplify this further, we will get x initial plus, this is 0, and this is 1/2 of, we can cross out this t and that, so that we get velocity final times t. And now our equation for the truck. The displacement of x for the truck can be written as velocity final times time, because we are not given an acceleration. So we can write that x final is equal to v final t plus x initial, because change in x is x final minus x initial, and we're isolating this variable. So we can compare this equation for the car, which is 1/2 vft, v final times t, for the truck, which is just v final times t. And we can see that this is 1/2 of this. So the truck will have traveled further than the car, which is represented as the answer D.